All right, next problem up. So in this problem, just like every problem, as always, I sound like a broken record. Read the question sentence first. So when we do that, it says, if the basket contains 63 pieces of fruit, how many oranges are there? Okay, so let's write that down. We're looking for how many oranges, and we know that this basket contains 63 pieces of fruit. So let me write that down one by one. We're looking for the number of oranges. Right there, nice and easy. That's blank. And then we see that the basket contains 63 pieces of fruit. So we have 63 fruit. And then we're looking for the number of oranges. So when we take a look at this first sentence, this is going to be very revealing in terms of what this all means. Because the first sentence says, hey, a fruit basket has apples and oranges in a 5-to-4 ratio. Oh, okay. So if we're dealing with apples and oranges, we're looking for oranges, but then we're given 63 fruit or 63 pieces of fruit, everyone, what's another word that I can use to represent just the word fruit? It starts with the letter T. You might have used it quite a few times in a proportion session. The word 63 fruit or pieces of fruit, yeah, that refers to the total. That refers to the total. So let me just write that down in a parentheses here. This represents the total. Because again, think about it. You're talking about a basket right over here with apples and oranges and all that stuff. I know I'm Picasso, I know. But when we talk about, hey, just 63 fruit in here, we're discussing a total. So that's going to be the big piece of information that's going to lead the way for us. Because, let me go ahead and write down the information we're given, erasing my fantastic drawing there. We see that, again, that ratio that we're given, let me write this in order. Apples were first, 5 was first. Oranges were listed second, 4 was listed second. So what I know is that I have oranges second, so I can say oranges right here equals 4 for sure. But what I can't do, the mistake that I cannot make, is just, again, what most people try to do, which is just, hey, I'm going to throw the number into the place that I think it goes in and hope for the best. That's what's going to get you into trouble here. Because if you do that, you're probably going to end up getting a decimal for an answer, and you're not going to be having a good time. So instead, everybody, let's think about this naturally. Everyone, if this 63 represents the total fruit, how can I get the total if I have 5 parts apples, 4 parts oranges? How do I get the total? Again, think about it naturally. It's not a trick question. Yeah, getting a total is addition. We're going to add. We're going to take the sum. And so with that, my friends, we can get the total here, and we can say 5 plus 4, that's going to give us 9. And so that's 9 parts fruit, total parts fruit. And so I can say 9 fruit right there, and now I'm in a good position. Now I can take advantage of that and solve this problem properly. So allow me to move this 5 apples out of the way because I don't need it there anymore because I have my proportion. I can compare total to oranges, total to oranges. Remember, proportions are all about comparing the same things in the same way. If you can commit to that idea and fulfilling that idea for all proportion questions, then we're in a good spot. So with that, here we go. I'll go ahead and use X for oranges because I certainly won't use the letter O. It'll look like a 0. So we'll go ahead and compare fruit on top to oranges on the bottom. So 63 to X right there. And then 9 to 4. Boom. Nice and easy. So here we have a couple of options. If you want to, torture yourself with handwritten calculations, sure. Let's go ahead and cross multiply 9 times X. And then we have 63 times 4. If you know your mental math here, you might get 252. But even if you're good at your mental math like that, then you're looking at, oh, now I have to divide by 9, and you'll get what you get beyond that. Another way to solve this, another way to do this, is by comparing. We can absolutely compare here and notice that, hey, right over here, 9 to 63, my party people, what do I multiply 9 by to get to 63? Oh yeah, that's going to be 7. And so whenever you notice a convenient situation, hey, don't shy away from it. Save yourself some time. 9 times 7 is 63. So going from the right side to the left side, that's times 7. So what I'm going to do on the bottom, same exact thing. That's the rule of proportions. Compare the same things in the same way. Everyone, 4 multiplied by 7, that's going to give us what? 28. There we go. And that's our answer. Boom. The number of oranges that we're dealing with is 28. So before I move beyond this problem, again, I want to remind you that we got this set up by comparing the same things in the same way. The problem was that we had 5 apples to 4 oranges, but that wasn't going to be sufficient because we had fruit to oranges, not apples to oranges. So to actually get fruit to oranges, we had to add the 5 apples and the 4 oranges. That's where the 9 comes from. That's where it comes from. So once you got the proper comparison, then we can set up our proportion and do our thing. Now, for those of us that wanted to see, again, the cross multiplication and division, I've got your back. X times 9 is 9x, because this will always work. Cross multiplication and division always works. And so then when we do the 63 times 4, I'll just write this over here. 3 times 4 is 12. And then 6 times 4 is 24, plus the 1 is 25. So we have 9x equals 252. And then lastly, we'll divide by 9 on both sides, just like that. And what we'll get is a cancellation on the left. And then 252 divided by 9, we can do our long division. 9 goes into 25 twice, because that'll be 18. Then we have 7 left over, drop the 2. 8 goes into 72, 8 times. So boom, we can get the same correct answer with a couple more steps, but it will still always work. So there we are. Our correct answer here is answer choice C, 28, because we made sure to set up the proper proportion before we started calculating. All right, next question. So in this question, we're trying to evaluate an algebraic expression, and all that means, everyone, is we're going to be replacing these variables with their actual values before we perform the order of operations, or PEMDAS, or however you like to call it. So let's go ahead here. We'll rewrite after plugging in. So we have 15 minus 2 times a, and a is going to be 3. So I'll go ahead and just plug in 3. And just a reminder that if we don't see, answer this question here, if we don't see an operation between a number and a letter, a number and a variable, what operation is that going to be, everyone? Yeah, always multiplication. So this 2a is 2 times a, and then 4b here is 4 times b. And b is listed as 2, so we'll swap b with 2. From here, again, it's just order of operations, and we know that we need to multiply first, and then we'll take care of the addition and subtraction. So here we'll rewrite. We have 15 minus 2 times 3, which is 6, plus 4 times 2, which is 8. Next up, we'll then do 15 minus 6, and that's going to give us 9. And then 9 plus 8 gives us 17, and we are all done. So again, just being careful at first, allowing yourself to plug in the right numbers for the right variables, and then from there, again, just order of operations. But nonetheless, the correct answer here is D, my party people, and we're ready to move on.